Welcome to the channel again. Time for disclaimer. Let's start the lipid series. Topic: lipoproteins. Lipoproteins are spherical complexes with a central lipid core and an outer amphipathic shell. The central lipid core of lipoproteins is neutral and contains triglycerides and cholesterol ester, while the outer shell is amphipathic and contains apolipoproteins, phospholipids, and cholesterol. Lipoproteins help in keeping the lipids soluble in blood and thereby helps in transport of lipids through it. There are 5 types of lipoproteins in blood. They are chylomicrons, very low density lipoproteins, intermediate density lipoproteins, low density lipoproteins, and high density lipoproteins. Chylomicrons VLDL, IDL, LDL, and HDL. The apoproteins are ApoB48 in chylomicrons, ApoB100 in VLDL, IDL, and LDL, ApoA1 in HDL, ApoC2 and ApoE in all lipoproteins at different stages. The lipoprotein transport pathways can be divided into two: forward cholesterol transport and reverse cholesterol transport. Forward cholesterol transport is divided into two: exogenous pathway and endogenous pathway. Exogenous pathway involves transport of lipids from intestine to peripheral tissues and organs, while the endogenous pathway involves transport of lipids from liver to peripheral tissues and organs. The reverse cholesterol transport involves reverse transport of lipids from all peripheral tissues to liver for excretion. Let's see exogenous pathway. Lipoprotein chylomicron, apolipoprotein ApoB48. This pathway transports lipids from intestine to peripheral tissues. The triglycerides and cholesterol from diet assembles with ApoB48 to form nascent chylomicrons. As chylomicrons travels through blood, it encounters HDL, which contains ApoC2 and ApoE. The chylomicrons acquires ApoC2 and ApoE from HDL. As chylomicrons reaches peripheral tissues, lipoprotein lipase present in peripheral tissues is activated by ApoC2. LPL degrades triglycerides in chylomicrons to release free fatty acids in the peripheral tissues. After releasing free fatty acids, it becomes a smaller chylomicron remnant, which gets transported to the liver. Chylomicron remnant is taken by liver through ApoE and receptor-mediated endocytosis and recycled inside liver. This is exogenous pathway. Let's see endogenous pathway. Lipoprotein VLDL, IDL, and LDL. Apolipoprotein ApoB100. This pathway transports lipids from liver to peripheral tissues. The endogenous triglycerides and cholesterol formed in the liver assembles with ApoB100 and forms nascent VLDL. As VLDL travels through blood, it encounters HDL, which contains ApoC2 and ApoE. VLDL acquires ApoC2 and ApoE from HDL. As VLDL reaches peripheral tissues, lipoprotein lipase present in peripheral tissues is activated by ApoC2. LPL degrades triglycerides in VLDL to release free fatty acids in peripheral tissues. After releasing free fatty acids, it becomes a smaller IDL and further becomes LDL. IDL is converted to LDL by hepatic lipase in blood and on liver. LDL is taken up by all extrahepatic tissues through ApoE and LDL receptor-mediated endocytosis. This leads to cholesterol deposition in tissues and atherosclerosis, making LDL the bad cholesterol. Both IDL and LDL also are taken by liver through ApoE and receptor-mediated endocytosis and are recycled. This is endogenous pathway. Now let's see reverse cholesterol transport. Lipoprotein involved is HDL. Apolipoprotein involved is ApoA1. This pathway transports lipids from peripheral tissues to liver for excretion. Lipids from both intestine and liver assembles with the ApoE1 to form nascent HDL. ApoC2 and ApoE synthesized in liver gets incorporated into HDL. As HDL travels in blood, it donates ApoC2 and ApoE to VLDL and chylomicrons. And as it reaches peripheral tissues, ATP binding cassette protein ABCA1 helps in cholesterol efflux from peripheral tissues to HDL. Cholesterol is esterified with fatty acid to form cholesterol ester by lecithin cholesterol acyltransferase, the LCAT. The LCAT is activated by ApoA1 in HDL. This is HDL3 and it accumulates cholesterol, becomes bigger HDL2. CETP, cholesterol ester transfer protein, transfers some cholesterol from HDL to chylomicrons, VLDL and LDL in exchange for triglycerides, relieving the product inhibition on LCAT so that it can take a lot of cholesterol. HDL then gets transported to liver. Scavenger receptor SRB1 in liver binds HDL and helps in uptake of cholesterol ester from HDL. Hepatic lipase degrades triglycerides and phospholipids in HDL. Cholesterol is used for bile acid synthesis or dispersal from the body through bile. This is reverse cholesterol transport. And these are the lipoproteins. Knowledge is joy. Let you be joyful all life. And signing off for now.